Hi everyone, this is Mrs. Musoff here. Today we're going to be talking about limits, and hopefully you watched that little intro video that I think shows some really good visuals as to what a limit is. We're just going to kind of dive in deeper to that. I'll show you a few examples, and then hopefully by the end of this you'll have a pretty solid understanding of what a limit is and how to get one from a graph. Alright, so when it comes to actually writing down limits, we use this notation. All right, we read it as the limit of f of x as x approaches c equals L. All right, and hopefully the video did a pretty good job of explaining this, but basically what a limit is it's describing the y value that a function is getting closer to as you approach a specific x value. So for example, take a look at these three graphs right here. Okay, these are just three different kind of possible graphs you could see, three of many possible graphs you could see. And just to kind of explain, it says the limit of f of x as x approaches 1 is equal to 2. And the reason that's the case is because if I put my pencil on this graph, this line, and I approach where the graph is when x equals 1. Right, as I approach x equals 1, the y value that I'm getting closer to is 2. And because that's true from both sides of the graph, not just one side, but from both sides of the graph, I am getting closer to the same y value, which would be 2. That's why we can explain that the limit is 2. Alright, even in this second graph here, where it still has a hole, the first graph had a hole, right? This one does too. But now there's kind of a separate definition for that point somewhere else. That still doesn't affect the limit, because the limit is just what's happening as we approach that value. So we don't care what the actual value is at x equals 1. We just care what the y value is as we approach x equals 1. And so once again, from both sides, since we're approaching this y value of 2, that's why we'd say the limit equals 2. Okay, and when we have kind of a continuous function, no holes, it's the same idea, right? As I approach x equals 1, what is the y value that I'm approaching? As long as it's the same on both sides, we would say there's a limit and it equals 2. All right, to give you a couple more examples, let me pull something up here. Okay, so just a few more examples to kind of understand. In this graph over here, it says the limit of f of x as x approaches 2. So I'm looking where x equals 2, and I'm trying to approach it from both sides. And I can see from both sides as I approach x equals 2, right? Watch that hand as I approach x equals 2. From both sides, I'm getting closer to the y value, -1. So that's why we can say the limit equals -1. Same thing in the second example, the limit of g of x as x approaches 3. So here's x equals 3. That means I want to approach that value. Here's me approaching it from the left side. Here's me approaching it from the right side. And no matter what, I'm still getting closer to this y value of 4. It doesn't matter that there's this actual point at y equals 2. I care about what I'm approaching. All right, that's what a limit is. All right. This third example is kind of the non-example, right? If you're wondering, well, what does it look like when there is no limit? This says the limit of h of x as x approaches -2. Well, here's -2. If I were to approach -2 from the left side, I'm using this line, and then the y value I'm getting closer to is -5. But if I were to approach -2 from the right side, now I'm on the other line, and this line, as I get closer to -2, is getting close to the y value 3. And so because those are two different values from the left side and from the right side, we would say the limit does not exist. All right, to show another example of that, let me switch back over here. Okay, right down here in your notes, you can see another example of that, right? So in this example that I've drawn here, we say the limit of f of x as x approaches 1. So I would look at my graph and I'd say, okay, here's x equals 1. If I approach it from the left side, the y value that it's approaching would be 0 because it's on that x-axis, right? So 0. But if I approach it from the right side, now the y value I'm approaching would be 1. So the fact that those are two different numbers, we would say the limit does not exist, or you can use d any. Okay, and that's what this little note here is saying. Because as x approaches 1 from the left, f of x approaches 0. But as x approaches 1 from the right, f of x approaches 1. Because the limits don't match, the limit does not exist. All right. Now we can have one-sided limits, and that is where we don't necessarily need both sides to match. Maybe I'm just looking for one side. And if we wanted to just find a one-sided limit, instead of writing as x approaches c, the number, we would write as x approaches c, and we'd have a little negative up where, like as a superscript. All right, that's saying as x approaches c from the left. Or it'd be a positive symbol, and that'd be as x approaches c from the right. All right, so if you ever see a little negative or a little positive, minus or plus, I guess, as a superscript, that means it's just looking for one side of the limit. And so a one-sided limit, it should exist, because you only care about one side. You would just look from that side what y value we're approaching. All right, so in this example, if I just wanted a one-sided limit, from the left side, it's approaching 0. That's what this part's stating. And from the right side, right over here, it's approaching 1. Right? Because they're different, that's why the overall limit does not exist. All right, so to show you kind of some more examples, actually this is separate from the notes, just kind of some other practice problems. We've got a graph here, and it says for this first part, find the limit as s approaches -2, and then it has that little negative, that minus sign. That means as s approaches -2 from the left of this function. Okay, so if I want to approach -2 from the left, the first thing I'm going to do on my graph is find where -2 is, right here. And then I'm going to get close to that value from the left side. So that means I'm following this line, approach, approach, approach. And I can see as I get closer to -2, the y value that I'm approaching is 1, 2, 3. Right there. Right. So that means the limit as s approaches -2 from the left of this function would equal 3. Okay. The next part, the limit as s approaches -2 from the right. That's this plus sign. So now from the right, that's over here, I'm going to start approaching -2. Approach, approach, approach. And again, as I get closer to -2, the y value is still getting close to 3. So that means my limit would also be 3. Now because the left-sided limit is 3, and the right-sided limit is 3, so because both sides exist and they're the same number, that means I can say my overall limit, so the limit of this function as s approaches -2, that's the overall limit, would equal 3 as well. Right? And in fact, p of -2 is saying what is the function defined as at -2. So instead of thinking approaching -2, now I actually want to know what is it at -2. So that's just basically saying at x equals -2, what is the y value? And right here you can see that point, the y value is 3 also. So actually all of these would give us 3. All right. To give you kind of another example of this, let me add to this here. What if instead of as x approaches -2, I was looking as x approaches 0, or s, sorry. So what if I said find the limit of p of s as x approaches 0 from the left? All right, well then, since I'm looking as x approaches 0, the left side of that would be over here. And so I'm going to approach 0, approach 0, approach 0, and the y value it's getting closer to would be 0 also. So the left-sided limit as s approaches, sorry, this should say, as s approaches 0 from the left, would also be 0. All right, but now what if I was looking at the right side? So the limit of this function as s approaches 0 from the right, right? That's that plus sign there, from the right. Well, now I'd have to turn to the right side of 0, which would be this graph over here, and I'm going to approach, approach, approach 0. Notice how it's going down and down and down forever and ever and ever. So what y value is that approaching? We would say that y value is -infinity. Okay, and now, since I notice the limit as s approaches 0 from the left is not the same as the limit as s approaches 0 from the right, that would tell us that the limit as s approaches 0 of this function does not exist, right? Because the two sides don't match. And if I was to go a step further and ask this last part too, where it says find p of 0, that's saying basically what is the point at x equals 0? Well, there is a point here at s equals 0, and the point has a y value of 0 as well, so that means p of 0 would be 0. All right, that's the idea of these limits. You've got some practice problems that you can do on your worksheet. Make sure you pay attention to the assignment and you only do the problems listed. That should be it for this first day. Write down any questions you might have. Make sure you ask your teacher when you get a chance. Take care.